Okay, so to integrate the indefinite integral from 1 to 2 of the dx over the square of 3 minus 5x, we're going to use the u substitution where we're going to make u equal to 3 minus 5x. That'll make then du equal to negative 5 dx. And we don't have a negative 5 dx, but we have a dx. And so we'll divide each side by negative 5. And so we'll get that negative 1/5 du is equal to dx. And so then we can rewrite this as the integral of negative 1/5 du. I'll put the du afterwards. And then we'll have the u squared in the denominator. So 1 over u squared du, like that. And then let's rewrite this as negative 1/5 times u to the negative 2 du. Now, again, we can't simply put the endpoints back as 1 and 2 because the endpoints are in terms of x. So what we can do is rewrite them in terms of u. And so when x is 1 and when x is 2, let's figure out what u would be. So when x is 1, u would be 3 minus 5 times 1. 3 minus 5 times 1, that means u will be negative 2. And so in place of that 1, we're going to put negative 2. I don't know what, I'm going to use pens to highlight that. And then when x is 2, u will be equal to 3 minus 5 times 2, which will be negative 7. And so we're going to put negative 7 as the other endpoint. So now we can just simply integrate this and then evaluate it with these, values because it's in terms of u. We don't have to worry about rewriting the expression in terms of x. So let's just go ahead and find the antiderivative of this. Let's go move this over here. And this will be simple because we can just use the reverse power rule. So we'll have negative 1/5 times u to the negative 1 over negative 1 from negative 2 to negative 7. And this will just be 1/5 times u to the negative 1, and then gradient from negative 2 to negative 7. And so then this will be 1 over 5 times negative 7 minus 1 over 5 times a negative 2. And so it's just an algebra problem now. And so 1 over negative 35 plus 1/10, it looks like. Let me just rewrite it like this, but this is just 1 over negative 35 or negative 1/35 plus 1/10. And we can rewrite this in terms of 70. So this will be negative 2/70 plus, and this will be 7/70. Now this 5/70 or 5/70, I don't know if I'm saying that right, which is the same as 1/14. Okay, let's look at this next one now. All right, so from here, we're integrating from 1 to 5, x over the square root of 2x minus 1 dx. And so we're going to start off by making u equal to 2x minus 1. Actually, no, we're going to make it, again, I already know what's going to happen. So your initial instinct was probably going to be to make u equal to 2x minus 1. which I would do initially too, but you're going to see that you won't be able to simply find the antiderivative. So we're going to make u equal to the square root of 2x minus 1. Now, we do this because we're going to look for u squared. So we're going to make u squared equal to, since we're going to square the square root, u squared will just be 2x minus 1. And then we take the derivative of this, as that'll be that we'll have 2u du will be equal to 2 dx. And then we just divide this by 2. And we get that dx is going to be u du. So u du will be equal to dx. That's the only part of this problem. This one's actually a pretty tricky one. So you're going to see what's going to happen. So that's part of it. That just takes care of the dx here. Now we need to figure out how we take care of that x. So what we're going to do here is just solve this for x. If we let's solve this for x by adding 1 first. So we'll have a u squared plus 1 is equal to 2x. And divide each side by 2. And then we'll have the u squared plus 1 over 2 is equal to x. And that x will be that part right there. So we have our u, we have our square root of 2x minus 1, we have our x, we have our dx. And so rewriting this in terms of u, we'll have the integral of, on the top, we're going to have u squared plus 1 over 2 in the numerator. In the denominator, we're going to have just u. This will just simply be all over u. And let me make this integral symbol a little taller so it looks more neat. And then we have the dx as simply the u du. This will be all multiplied by, let me put that u du. Kind of looks weird, but all right, that's fine. Now, you're going to see these u's cancel. So let's make this now simply u squared plus 1 over 2 times du. And so that makes our integral a little easier to work with. So it's just u squared plus 1 over 2 times du. Now let's change these endpoints in terms of u. So we have x is 1 and x is 5. And let's rewrite these in terms of u. So when x is 1, u will be the square root of 2 times 1 minus 1. So u will just be the square root of 1. So u will just be 1. So coincidentally, it'll be the same thing. And when x is 5, u will be the square root of 2 times 5 minus 1. So you'll be the square root of 9, and then you'll be 3. So our endpoints just change from 1 to 1 and 3. Now we're going to find the antiderivative of this expression. Now, all we need to do here to make this easy to integrate is to break it into, 2 pieces. So we're going to make this as u squared over 2 plus 1 over 2 du. And then we just integrate these individually. So the antiderivative of u squared over 2 will just be u to the 3 over 2 times 3. And the antiderivative of 1/2 will just be 1/2 u. And we're going to integrate from 1 to 3. So this 2 times 3 just becomes a 6. So now we just evaluate this. So we're going to have u cubed over 6. Let's write this as 1/6 u cubed. And let's put the 3 in for the u. So 1/6 times 3 cubed plus 1/2 times 3 minus 1/6 times 1 cubed plus 1/2 times 1. This is just algebra. And this is actually where I get a little paranoid because I freak out that I might mess up on a simple algebra calculation. Which is, yeah, so let's see if I don't. Hopefully I don't. So 1/6 times 3 to the 3/3. So 1/6, 3, 9, 27 plus 3/2 minus 1/6 plus 1/2. So 1/6 plus 1/2. This 1/2 will just be like 3/6. So 1/6 plus 3/6, that'll just be 4/6. Just working the algebra out. So we're probably gonna want to make this in terms of 6. So 27 over 6. So 9 over 6. 27 over 6, divide both by 3, or not 9 over, well, let me just divide them both by 3, 9 over 2 plus 3 over 2 minus 4/6, which is actually just 2/3. Let me just leave it as that for now. And then we'll get 12 halves. We'll just get 6. We'll get 6 plus 6 minus 2/3. And we'll get 5 1/3, or just, that'll be 16 thirds. 16 thirds will be our final answer. All right. And that's all there is to it.